Let's consider 1/4 plus 3/5. So there's multiple ways to solve this, and eventually we'll be moving to a way of solving this with multiplication. But before we do that, it's important to understand why that works. So here is a visual method which you can use to solve this problem. And basically what we're doing is looking for a way to find two fractions that are the same amount but have the same denominator. Right now we have two fractions with different denominators, and so we can't add them together. But if we convert them to fractions with a common denominator, or where both denominators are the same, then we can easily add them. So let's start with 1/4, and we're going to model 1/4. And so one way we can do that is by dividing this square into 4 parts. And I have one part, so I'm going to shade in 1/4. And over here, so there I've modeled 1/4, and I can label that. Over here, I have 3/5, so instead of dividing into 4 parts, I'm going to divide this into 5 parts. One common mistake that people make when they're dividing a square into 5 parts is they will make 5 lines. But as you see, in order to divide this into 5 parts, 1, 2, 3, 4, 5 spaces, I've added 4 lines. So we have to be clear about the difference between the spaces and the divisions between them. And so that takes a little bit of thinking. It's always, if I want to divide it into 5 parts, I make 4 lines. If I wanted to divide this into 3 parts, I would have 2 lines. If I wanted to divide it into 6 parts, I would have 5 lines. So it's always one less. The number of lines we're adding is always one less than the number that we're going for. So here I have 3/5, and I want to color in 3 since my numerator is 3. And at this point, we're still in the same boat. We still have two fractions with different denominators, and we still can't add them together, even though we have models. So the next step is to find two denominators, or one denominator that'll work for both. So an easy way to do this is take the number of divisions that I have on the other fraction and add it to the fraction, to this fraction. So since this fraction is 5, I'm going to go ahead and break this horizontally into 5 parts. 1, 2, 3, 4 lines gives me 5 parts. 1, 2, 3, 4, 5. And now, if I look at it, I have a new denominator. Okay, so here I have 5 times 4. My new denominator is 20. And I can just count here to figure out what the numerator is. 1, 2, 3, 4, 5. Now you might be saying it's much faster to multiply and to do this without drawing models. And that's true if you understand what to do. So the goal of this modeling is to understand why the multiplication method works. And hopefully, once you have a solid grasp of it, that is something that you'll remember forever and not have to memorize. And you'll always have a way of figuring it out if you get stuck and you can't remember the steps. So here I have divided into fifths. I want to look at my neighbor. I want to divide it into 4 parts. So I'm going to divide it into half. And there I have 4 parts. Again, now I still have 4 times 5, so my denominator is 20. So we have a common denominator. And now I have 3 by 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or 3 times 4 is 12. Once I have a common denominator, now I can add those. 5 plus 12 is 17. And it's 17/20. So later on, we will learn that you can take 1/4, and if you multiply that by 5 over 5, we will get into 5/20. We haven't covered multiplication of fractions, so this is something that students may not understand yet, but parents do understand. We are going there. It's just we're trying to develop some understanding before we get there. So this is the end goal, to be able to do this quickly, but with understanding. So right now, modeling fractions is a really important way for students to build understanding of fractions and why we need to search for a common denominator to add them together. So hopefully that helps, and good luck.